Hi, everyone. Welcome to this Prime Talk, a conversation platform from ET Prime, where you get to hear from the experts deep insights on issues that matter. Today, we are going to talk about something that I personally believe is the hidden pandemic, tucked away from our eyes primarily because a virus decided to take center stage. If it had not been for COVID, media, both in India and abroad, would have been talking about the semiconductor shortage a lot more. Think about it. It has already impacted pretty much every country in the world, has caused prices of electronics to climb dramatically, doesn't show signs of normalizing anytime soon, and has created a burst of supply chain nationalism all across the world. It seems to have changed the world for good. India, too, right now is just announced a $10 billion push to manufacture chips after several false starts over the past couple of decades. In today's conversation, we aren't going to concentrate on the things that led us to this mess. Instead, what we're going to do is try and look forward and make head and tail of what will get us out of it. To do that, I have three awesome people here. One is Swapnil Jain. Swapnil is the co-founder and chief technology officer of Ather Energy. And he will bring in the perspective of the automobile industry, which has been one of the worst hit in this unprecedented shortage. Barnik, Maitra, he's the managing partner of India and South Asia at Ather Energy. And he will talk about the various ways in which changes come to businesses as well as nations on how they deal with wafers of silicon. The third person we have is David Loftus, who heads the Electronic Component Industry Association, and he will talk about how long this semiconductor shortage will last and how the industry itself is fighting back. Feel free to ask us questions, all of you who are hearing this, and I'll try and accommodate a few of them towards the end of this conversation. Without much ado, I will get straight into this Prime Talk. I will start with David. David, when are you expecting supply to normalize?
Well, first off, thank you for having me. I think that I can say that we expect that supplies will start to normalize toward the middle of 2022. It's somewhat hard to predict from a number of reasons. I guess first off, we didn't get into this all at once, and we're not going to come out all at once. There will be certain components, certain types of commodities like memory, like discretes that are very, very tight right now that will start to loosen up as a number of things happen. One, the business cycle starts to abate. Second, stimulus around the world that where countries have pumped $20 trillion US into economies around the world starts to dry up a little bit. And we should start to see again, middle of 2022, a lot of this tightness start to ease and lead times return toward the normal ranges. And then really by the end of 2022, beginning of 2023, also as new capacity comes online, I think that we're going to see a much more normalization of the market.
Right. I'll go to Swapnil now. Swapnil, how did the shortage impact Ather? And what changes have you implemented to cope up with it as you scale? As per my understanding, it's really a matter of concern when you scale rather than at the volumes you had, say, 1 year back.
Thanks, Nirmal, for having me here. As you rightly mentioned, the fact that we were working at lower volumes until now, it hadn't impacted us significantly. Also, we had learned from the past when we launched our first product. At that time itself, there was a huge shortage of capacitors, especially MLCCs in the market. So we had learned in the past, and we had sort of prepared ourselves. Our systems were sort of designed to handle this sort of a situation. So I would say until now, we haven't been impacted significantly. As our volumes are starting to go up, we are seeing some challenges which are coming our way in the coming months. We have been able to sort of navigate around it by sort of finding parts in the open market, and we have been able to sort of barely make it with our production requirements in the previous month. I think in the coming months will test us really hard, and we are doing all what we can to sort of keep up with the expectations of the market.
Right. I remember writing a story back then when you had the capacitor issue.
Right.
So I did not know that this is going to become such a big issue in just 2-3 years later. Barnik, I think clearly automobile industry has been one of the worst hit over these last year or so. What can we learn from the woes of the automobile industry?
I think there are several things to learn, I think, and what we learn from chip shortages is actually applicable to healthcare systems and everything, right? I think the old paradigm of just-in-time, Toyota production system, efficiency-oriented supply chains don't work in this modern world of volatility and don't work in a world where you will have such demand-supply, I would say, mismatches far more often than people anticipate. I think what is very surprising to me, and I remember, Nirmal, we spoke first in January that there is a chip shortage hitting the auto industry. The magnitude of the impact is stupefying, right? I remember when I spoke, I'd also given you a quote that GM and Ford will be impacted to up to $5 billion, right? I think the numbers are 2-3 times of that. I think the industry is around impacted by anywhere between $150 to $2 billion to $200 billion of lost sales, right? Because they did plan enough, right? So I hope automakers and other supply chain folks learn simple lessons, right? Diversify your supply base, right? Get closer to your supplier. Don't always believe in just in time, right? You need to build resiliency. You need to build inventory, right? I think for chips, I think there is a bigger push towards open standards, right? And open software, right? Trying to optimize your system to be more software than hardware driven, or some lessons, right? And to be fair, if you look at learnings from the electronics industry, the smartphone industry, Apple and Samsung have not been remotely hit by the chip shortage. I think you can say they were hit by 2-3%, right? Because they were ready, right? They had the supply locked, right? They had the fabs locked, right? And so all the things you can learn from the, I would say, supply chain prowess of Apple, right, is what you can learn for the auto industry, and other supply chain should also take note, right? I will talk a little bit about the balkanization of the supply chain, but that's going to be one of the biggest restructuring of the global semiconductor industry as we speak, right? Because of this supply shortage has accelerated or accentuated the risks of depending on 1 or 2 countries supplying all your semiconductors.
Right. It's interesting you mentioned our conversation back in January, Barnik, because I remember writing that precise thing that $5 to $10 billion would be the loss. And then when I revisited the issue sometime in June, that number had ballooned to I think it was 50 billion of sorts, which the consultants were saying. And then right now, when I just wrote a piece on the semiconductor industry shortage, the automobile industry hit, that number was around 200 billion. So yeah, well, it grew with the year, I suppose. David, you are an insider, right? And you have had a great vantage point of the steps that the industry has taken. And here I'm talking about beyond the new fab units, right? I mean, 29 odd fab units that you mentioned earlier to me, in an earlier conversation. What are the steps that the industry has taken broadly to ensure that this kind of situation does not repeat?
Well, I don't know that you can guarantee that ever that there's that we're not going to have tightness in the future. If you look at history, the semiconductor industry has moved sort of on a boom bust cycle like clockwork every 4 to 5 years for the last 40 to 50 years. And I'll say that, there are a lot of really good lessons being learned on both sides. Number one, I think that the industry probably was just slightly behind in capacity building coming out of the last cycle, just because there was so much effort to be able to be able to go to what's called an asset light model and to be able to embrace outside foundries. And I'll say that a lot of people are looking at making sure that they guarantee capacity both on the foundry side, and also a lot more people are incentivized to be able to bring on more of their own capacity where they can. The other side of it, the other lesson is, as Barnik mentioned, people are really focused now on supply chain resiliency, where all these automotive companies were focused on just in time, and they had also sort of forced themselves to be direct customers of most semiconductor manufacturers. Now they're really looking at further embracing the authorized channel for components, working some distribution into their mix of procurement so that they can cushion some of these huge demand fluctuations. But let's not forget, right now, we're in a once in a lifetime, hopefully, kind of situation where the volumes have absolutely gone through the roof. If you look at overall semiconductors are going to grow 26% in 2021 versus 2020. That's massive, and another 9% in FY22 to over 600 billion US dollars. There are certain pieces of the market, like analog ICs, logic ICs, that are up 50% from the beginning of the recovery. And so, while there is tightness and it is very painful for a lot of people, we're running at record levels as people are spending more time at home and spending more of their disposable income on electronics and other goods that include electronics. So we're running at record levels and really trying to catch up absolutely as fast as we can.
Right. David, I do have a few questions on some of the things that you've mentioned, but I'll first go to Swapnil and get a sense of something that Barnik had mentioned earlier, which is the software as a tool to bring in more efficiency. There have been these conversations going on for a while now, and translating sort of more efficient use of software to use semiconductors more efficiently, that is. How do you see this as a CTO? How do you see this happening both across the industry and for Ather?
I think a bit of what Barnik mentioned and David mentioned, and also I see there's a question on, does the auto industry use outdated chips? I think these are sort of related. I would say that automotive industry has been like the most of the supply chain for the automotive industry has been something which serves just the automotive industry. But when it comes to electronics, it's not just it is not just the automotive industry which it serves. The electronics is served. A major portion of it is actually the personal devices sort of things, and it's a big shock for the automotive industry to sort of be like a minority player in the supply chain. And I think the biggest learning, I think, for us, for automotive industry is that we have to actually align with the consumer electronics industry, then try to demand something specifically for automotive industry, because the automotive industry volumes are unfortunately lower than the consumer electronics, and probably that might continue to be the case. And it's better to align with the consumer electronics industry than to have demand a separate automotive product. And to that extent, what for example, what we are trying to do is try to use more general purpose ICs than to try and use any special purpose ICs, because general purpose ICs are used by multiple players, and then there's always going to be a bigger pool requirement for it, and it's because it's also used across multiple players. It's a lot easier to get parts around it. If someone doesn't buy it, you get it, right? But if it's very specifically created for your requirement, then you might not actually get it. So and their software plays a big role, because if you're using general purpose ICs, then it means that you have to write a lot more logic on top of it, which means that your software has to be a lot more robust. But if you have written the software yourself, then it gives you the flexibility to move from one IC to another IC in a lot more flexible manner. So I think, yes, software plays a big role to make hardware not very specific to your requirement and be able to use multiple hardware. And that's where we are trying to move as well. We already had moved to a lot of general purpose IC in our current architecture compared to our previous architecture. And as we are moving ahead, we are still again focusing more and more on getting rid of special purpose ICs and using more and more of general purpose ICs as much as possible.
Right. I guess, Swapnil, that one of the things that the listeners and viewers can take away is that you will be hiring more software engineers.
Oh, definitely.
Right. Barnik, you mentioned something very interesting earlier about Apple and Samsung, right? But then that sort of luxury can be afforded to Apple and Samsung because of the scale that they operate in, right? What would be some of the learnings in terms of relationships, creating industry relationships that smaller players can take away? Is one of the things that David had mentioned about going through distributors, going through established systems rather than one-on-one relationships. Would that be the kind of direction that they need to take?
Yes, and I think remember, the challenge with automakers is that automakers, as I think Swapnil also adhered, right? If you look at the global semiconductor usage, right, and David, please correct me, or the expert, I think around 10 or 12% of semicon is actually used by the auto industry. So they're actually not a big consumer, right? I think when you're a marginal consumer, if you're not being proactive about supply, you will always get locked out of supply first, right? I think it's a fact of life, right? So I think if you are today sitting inside an auto manufacturer, I would do several things, right? One is I would revisit the way I have structured my contracts, right? With either the channel or even directly with the fabrication units, right? I would ideally and like to, even though I may dislike it as an auto player, I may have to commit to volume guarantees, right, which are 3 to 5 year volume guarantees, so that whenever there is a peak demand, at least I have access to minimum supply. I cannot come every quarter into the market and say, listen, I'm going to procure X thousand chips and all of that. I would need to, if need be, right, if there are new fabs which are coming up in the next 2-3 years, I would also, as an automaker, consider co-investing into those fabs to get, again, a minimum volume guarantee. So again, in this world, it's about how you lock up some volume for yourself, right? So that you don't run into a situation when demand suddenly goes hot. You can only deliver a car in 9 months, 12 months, which actually is revenue lost, right? So that's one big change, right? The second big change is actually the software angle, which Swapnil mentioned, right? I think car makers like Tesla have proved that you actually have to own and build the software which optimizes your car platforms, right? Whether it be electric vehicles or automated driving, right? And again, I don't want to get into the specifics, right? But this is a unique in-house capability you need to have on smart compression, on compilation, which if you have great distinctive capability in-house, you can just reduce the number of chips you use in a car, right? And again, I'm not saying I've seen any automakers do this at scale or well, but if I talk to some of my friends, not in the auto industry, right? But if I talk to the folks in the in other industries who are actually trying to own the software, there are ways, right, where you can get ahead of the curve, right, and use even software more effectively than just using standard chips. So again, there are several things for automakers to consider, right? And the automaker of the future has to think of themselves like a technology player, a software player, or a hardware player, right? I think the assembly game and the distribution game is now table stakes, right? For you to be distinctive, you have to be a technology player, you have to be a software hardware player, and you have to think the same way Apple and Samsung thinks, right? The way they manage their supply chains.
Swapnil is not going to be happy because his hiring costs will go up. But David, we've mentioned earlier about like the number of fabs that is coming up right now. 29 is the number you had mentioned earlier. There is a very real danger of overcapacity in a few years' time, which is the other extreme from the situation we are in. And I found that very interesting, right? Why are we swinging wildly like this?
Well, I'll say that there's not a desire to be able to get into an overcapacity situation. And I know that CEOs and CFOs in corporations all around the world, semiconductor corporations, are going to watch the market very, very closely and try to slow some of these projects down if business conditions turn suddenly. But it is a very real possibility. And actually, there's another angle to this cycle that is somewhat unique in the history of the semiconductor business, and that's all the geopolitical struggles that are going on right now. When you talk about U.S. and China and Europe and all these and the China-Taiwan situation, there are all of these issues with people trying to governments really trying to push more onshoring to be able to ensure supply, to be able to ensure national security. It's and that those incentives that are being put before corporations can also add to the challenge of trying to keep the capacity planning correct. So there is a chance that there could be some overbuilding, and then that is not the best thing for the industry long term or for customers. If we bring on a lot of added capacity, and these are very, very expensive factories, from $2 billion to well over $10 billion for some of the most advanced high capacity fabs. If these 29 plus fabs get put online and you've got hundreds of billions of dollars US of capital expenditures, and that remains idle, manufacturers are not going to just take the loss on that. They're going to pass along cost increases onto the market to be able to cover that excess capacity. So right now, when everyone's scrambling for parts, they're all screaming, bring on more capacity, bring on more capacity. But when the market changes and the demand softens a little bit, then the market is going to be happy that if we didn't bring on too much capacity.
Right. I think the question really is, are any of these new fabs going to be commercially viable, right? I mean, that's the big worry.
Well, absolutely, they'll be commercially viable. If you look at the amount of capacity that's coming online, it's not an extraordinary amount that is going to double the capacity overnight. There are enduring trends that are going on in the marketplace with 5G, with more intelligent vehicles, with IoT, with so many different things that are going to continue to drive sustained semiconductor growth over time, over the next several decades. The challenge is that we will still have some boom and bust cycles along the way, and it's a matter of trying to balance bringing this capacity online to be able to handle more of the peaks, while not bringing on so much capacity that we are inefficient as an industry, delivering parts for the lowest price for everyone that needs electronic components.
Right. Swapnil, I'm going to combine my next question with something that Ajay has asked on the Q&A. Will the auto companies be forced to change their product offerings going forward, considering chip shortages faced by them? Meaning, will they be less keen to offer high-end products? My question was, looking ahead, how does it impact product roadmaps, both for Ather and across the industry?
Right. It's hard to say right now. I mean, like as an OEM, obviously, I would want to provide the best product for the customers. Now, in a way, the good thing is that with electric vehicles, you just cannot build an electric vehicle without semiconductors. You need semiconductors, and once you have the base semiconductor in place, the features aren't really too much of a cost. It's as we have been talking about, it's all software, right? Like we have to just once you put the chip in place, then you just write more software on top of it. It doesn't cost you much. So I think the product offering maybe on the 4-wheeler segment may be possible with autonomous and all, maybe a bit compromised, but I think on the 2-wheeler segment, because there is most of the intelligence can be built in with the base hardware itself. I believe the compromise might be lesser, but yes, there is a possibility if this thing does not fix in next 1 year, there could be, because as the volumes start growing up, there could be certain compromises which OEMs might have to make. Hopefully, we'll come up with a solution by then. But if not, then yes, there will be some compromises which might come up on the product offerings.
Right. That's a sad reality of all of this, I guess. I think there is a lot of conversation around, and David mentioned this earlier also about the geopolitical angle. And Barnik, I'm coming to that, right? Countries across the world have reacted strategically to this shortage. What have been some of the broad trends that you've noticed? You mentioned that the whole nationalism bit, chip nationalism bit, is in vogue right now. So one question is around how the world has reacted, and the second is, how do you rank, in that world where the way India has reacted at this issue? We know that we had a conversation yesterday about India's $10 billion push into making itself a strategic semiconductor production manufacturing base. Is that enough? What do you think?
Yeah, let me start with the first part of the question as to what countries have done, right? And I'll actually start by linking an answer to David's reaction to when you asked, are these fabs going to be commercially or financially viable, right? My short answer is yes, because they're all financed at nearly 0% cost of capital, right? And if your financing costs are low, even if you see a boom bust cycle over the long term, you will see them viable. So I think strategically and a lot of them, right, by the way, across the world, people are committing tens, if not hundreds of billions of dollars to these fabs as governments, right? So let's get to the balkanization or the, I would say, the fab nationalism point of view. I think what I found interesting of the 29 fabs which David mentioned, right, I actually did a little bit of research last night to see where these fabs are coming up, right? Not surprisingly, but around 6 of them are coming up, 8 of them are coming up in China, 8 of them are coming up in Taiwan. I was actually pleasantly surprised to see 6 of them are coming up in the US, right? In fact, I think around Arizona and the Midwest, right, there's a big push towards that. Europe is coming up with a few, right? And Japan and Korea are coming with 2. I saw some news on Singapore also doing a fab, right? So I think in general, we've seen a lot of interest, right? And if you go back 5-10 years back, I don't think you will ever hear of a fab coming up in any of these countries, right? If you look at the policy front, I think the Biden administration has committed over $50 billion, right? To this, I think there's a new act, I think it's called Chips for America or something, which is, I think, somewhere in the Senate, which is getting debated. I think the European Union has also committed some money. South Korea has committed a $500 billion investment in something called a K corridor, where I think SY Hynix is going to create, I think, 10 or 15 new fabs, right? So I think in general, people are seeing that this is an opportunity, and obviously the China +1 thesis plays out. So this is interesting. It creates space for a country like India to also dream that they can do fabrication and they can go up the value chain, right? So again, as we go forward, assuming that the liquidity continues, the demand spike doesn't stop at least for the next 5 or 6 quarters, right? Even though the chip shortage may ease, I will expect to see probably more fab announcements by countries outside North Asia, fabs which may be up and running in a 25 to 27 kind of a time frame, right? So again, I think people are realizing this is a critical component of domestic security, national security, and you don't want to be dependent on only 1 or 2 countries. Now let's talk about India. I think the story of India is quite interesting, right? I think 5-6 years back, there was a new subsidy policy which was subsidizing $1 billion or $2 billion for a couple of fabs. Then I think the government made a little bit of a pivot saying, this is too expensive, we can't afford it. Let's focus on outsourced semiconductor assembly and testing. And if you see that that's where some of the push is, right? India has already done a fair bit of engineering service outsourcing for chips, right? You'll find centers like AMD, Intel do some software work. So again, to be fair, these are all at the fringes, not really solving a fundamental problem that we are actually spending a lot of foreign exchange on importing semiconductors and panels, which we could make in-house. I think the good news of the recent announcement or the rumors, I think $10 billion is a sizable money. I think it should allow us to subsidize probably 2 or 3 viable fabs. I think I'm hearing that the government wants to probably put this money towards 1 or 2 big panel fabs and maybe some small semiconductor assembly. Again, here, I believe small is more beautiful. The government should try to divert most of these resources to 1 or 2 more likely successful pilot projects than try to democratize it and spread it over 20-25 projects. Because if you look at what governments have done over 70s, 80s, and 90s, all countries have created a fabrication ecosystem by investing billions of dollars, right, to literally create the ecosystem, get the technology and transfer it, right? So I believe that it's a good step by the government, right? I think it may be 5 years too late, right? In a way, because if we had this investment 5 years back, our fabs would be completely hot and running today. But again, it's a step in the right direction. Welcome the move. I would again encourage the government to not spread this investment over too many fabs, but spread it over a few select fabs with higher possibility of success, then democratize it.
Great. David, what are the challenges that are there for a country like India as it tries building these fabs? One of the things that I've wondered personally about is the appetite which global semiconductor players like a TSMC or a Samsung might have to partner, because there is some amount of technology transfer that needs to underpin some of these fab manufacturing push. So what are the challenges, and is there appetite for partnerships in the world right now?
I think there's definitely opportunity for partnership. I think there's definitely opportunity for India to be able to step up in semiconductor production. I guess the challenges, a couple of them, Barnik has mentioned. Number one is just it's incredibly capital intensive, and especially if you want to be at the bleeding edge of technology, it's $10 billion minimum to be able to put into a 5 nanometer, 3 nanometer fab. And it takes deep pockets, but it also takes tremendous depth of technical expertise to be able to even build these, let alone run them and run them efficiently to be competitive in the world market. You've got people that are decades ahead. So it will take a very focused effort on the part of India. And the good thing for India would be that obviously it's thousands and thousands of really well-paying jobs, and it brings a lot of industry around it that can blossom around the semiconductor fab market. Certainly the back-end assembly and test, as Barnik has mentioned, is a real good addition as well. The challenge that I think any country has is that as much as a country country's officials want to believe that they can build national security by having more fabs at home, no one is going to be able to corner the market on semiconductors. No one government, even China or the US, throwing tens to hundreds of billions at this, is going to have 100% of the bill of materials for Swapnil's engineers. For Swapnil's engineers to be able to build the best product for their customers, they're going to want to look at the innovation from dozens of companies that build all around the planet. This is truly a global industry. And while you might be able to alleviate maybe a little bit of capacity in memory here or a little bit of capacity on discretes there by building locally, the amount of building that's going on and the amount of innovation that's going on around the world will continue to keep this a global business for a long, long time. And so we need to learn to work with one another. I think it's great for India to be able to want to add to the innovation. And India has wonderful, intelligent, motivated people to be able to make that happen. But I think just the thing to remember is there's no such thing as one country being completely self-sufficient in this, and it won't be that case for a long, long time.
Right. Swapnil, as one of the few companies that I've seen personally, which has built a hardware product in India right from the design stage. I was just wondering, what does it take for private players who will, of course, have the government's help in creating these fab units to make it a success? What will it take from a hardware point of view?
I think along with the capital, which is obviously the most intense thing here, is the knowledge which is required to run something like of this sort, right? And I think, as you rightly mentioned, that though we have a lot of knowledge on design, like we have done a lot of design services on semiconductors, chip designs, but we haven't had anyone who's actually run. We have not actually I've not gone too deep into semiconductors, but we had spent a lot of time on cells. We were trying to figure out how lithium-ion cells can be manufactured in India, and the similar problems existed there as well. That we had a lot of people. Well, at least even with lithium-ion cells, even the design was a problem. But even if we could crack design, there are very few people who know how to run a lithium-ion plant, right. and trying to set up and most people are afraid to set up something which requires such a huge capital without a partnership, and partnerships are hard to find, right? So I think that's the biggest challenge which as a country we will face, that having the right talent or rather having the right talent or having the appetite to make some mistakes while doing this and paying the price for it. I think that's going to be quite crucial as we venture in this direction.
Right. I'm going to just look at a couple of reader questions. Sumit Chabra had earlier gotten in touch with us and had mentioned and asked this question on the mobile handset industry. I think he means beyond Samsung and Apple, right? The smaller players. There was some news of late that there is a shortage there, and when improvement is expected for those players. Barnik, do you mind taking this?
I have heard of mid-end to low-end smartphones that new releases have been delayed by a quarter or so. But again, it is not as prevalent as auto. I don't know if David, you've picked up something, but again, most folks who are doing smartphones which are in the $200 to $500 range have typically delayed new model rollout, which is where the bulk of their sales are, by a quarter or two, right? I haven't seen significant delays beyond that.
Yeah, I would say that cell phones are almost in the same boat as automobiles these days. When in the beginning there was a much larger impact to the automotive industry because they were a lot of automotive manufacturers were sort of late to the game in putting orders on the books toward the end of 2020, and they just encountered longer lead times to be able to get those initial orders. Now it's getting to the point where it's just whoever puts the orders on the books is going to have some extended lead times. And the way that we track it in our association, lead times have continued to extend. Even though I say that things are going to start to ease toward the end of to the end of 2022, right now we're still seeing record lead times, and that's for record lead times for automotive, record lead times for consumer chips, record lead times for communications chips. Fabs are running absolutely flat out. And it's just a matter of who's able to have foresight to be able to have orders on the books to be able to get in line for that capacity, unfortunately, right now.
Right. Nachiket has asked a question: how are VCs responding to the electronic startups? Would any of you?
No, I can give a short answer. I think very enthusiastically is my answer, right? If you look at 2020, 2021, I think they've pumped some $15-20 billion into the chip-related industry. This is nearly 10 times of what the VC inflow into the chip startup industry was in 2015, 2016. It's nearly up 2 times since 2019, right? And you have to remember where the inflow is. I think the inflow is fundamentally on design. It's on reconfiguration. It's for folks who are making chips for newer use cases like 5G, IoT, gaming. And this, if any, and again, if you're today sitting as a VC, right, I think what is very exciting for you is that fundamentally pricing of semicon has gone up, right? And it's expected, and even though it's a boom bust cycle, I think the amplitude of this curve is unprecedented. Right. So today, if you're actually contributing to this industry, you're looking at the prices and seeing quite attractive returns. So again, It's a great time to be working in the space, even as a startup, whether you're working in design, whether you're working on even fabless chips, right? There are lots of cool areas, right? And VC interest has only multiplied over the past few quarters.
Right. I think the acquisition of ARM holdings would have also influenced the VC thinking around this, I'm guessing. There is a question on, okay, this is interesting. How real is the threat of China taking over Taiwan and consequently, impacting the semiconductor industry? And I think, well,
that's so I'll take a shot at that. I certainly think that Chinese understand very well the kind of challenge they would have with governments and customers all around the globe if they attacked Taiwan militarily and took over a huge part of the world's semiconductor supply. That would just be, I think it would be almost catastrophic when you talk about supply chains around the world if that were to happen. And I think the backlash would be unprecedented. At the same time, China's going to continue to try to press Taiwan, and they're going to continue to challenge the world from just the geopolitical challenges. And it's going to be an ongoing political battle about just making sure that at least from a semiconductor perspective, that market continues to be free and open and unfettered by these geopolitical issues. So while I'm mildly concerned about it, I think that hopefully there are cooler heads that prevail on all sides to be able to ensure that we do keep the flow of electronics that's absolutely vital coming out of Taiwan.
Right. I think I'm going to sum up now. Most of the other questions, I think we've tried to answer them over the last 40 odd minutes. I think, like COVID, this is clearly not over yet. It's also changed so many things for good. What is especially perplexing is this possibility of the other extreme, wrecking, some impact, the oversupply bit that you guys have mentioned. Let's chew on that for a bit. It was a fun and rather interesting conversation for me. I thank all the panelists as well as those who've joined us to hear them. And I thank the team that has worked with me on this to make this happen. Thank you.